What's up everyone, it's Mr. Lang, and in this video I'm going to teach you how to find the domain and range of a function from a graph. So all you need is a sheet of paper and a pencil and you're good to go. So let's get started. Alright, I'm going to start you off with some definitions that you already know. First one is domain. The domain is all the possible x values of a graph. And when you hear domain, I want you to think left to right. Alright? Now the range is all the possible y values. And in this case, I want you to think down to up. And it's easy to confuse the two. So one way that might help you remember it is to write domain and range like this at the top of your paper, or, up in the corner. It'll help you remember that the domain is left to right, the range is down to up. All right? Just a little trick. All right, we're going to do 4 examples, and hopefully you'll be good to go after that. All right, example 1. Take a second and copy this graph down. It doesn't have to be perfect. In fact, you don't even have to number the axes. Just make sure you get the points down in the general place where they are, and label them and get the coordinates. So take a second, pause it, and start it up again. All right. So example 1 here. This is called a discrete function. All that means is that we've got points scattered among the graph here, and they're not connected by lines. So this is what's called a discrete function. They're really easy to tell. Well, what's nice about the discrete functions is that the domain and range is super easy to get. So the domain, again, is all the possible x values. So all we have to do is list all the x coordinates for each of the 4 points. So I'll just go in order from A, B, C, D here. So the x coordinate for the domains here are A has a 2, the B has a -4 as an x, C has a 0, and D has a 6. So the domain would be these 4 numbers. A lot of times you see the domain and range encased in curly brackets like this. It's okay if you don't have them. I'm not going to take off points or anything, but just so you know what they look like. Now the range is all the possible y values. So again, we're going to look at the y's. So we got a 3 for an A. B has a 1. C's y value is -5. And D's y value is 0. And I'll put those in the brackets too. That's it. So discrete functions are super easy to find the domain and range. All right, let's get to a more interesting example. Example 2 is a linear function. And this would be considered a continuous function because all the points are connected. So, again, take a second, draw a diagram that looks somewhat like this, and then unpause it. So, first off, the domain. What I like to do is take my pencil or my finger or whatever, and I like to go left to right. And because this line has an arrowhead pointing to the left, you can see that it would keep going and keep going and keep going. We just don't want to draw that. But it would keep going left in the x direction. It would hit all x values going towards -infinity. And if I kept going to the right with my pencil, I would keep going towards positive infinity because although this is pointing up, it is pointing to the right infinitely. So one way we could say the domain is to say that it goes from -infinity to positive infinity. And the way we write that is with the and notation. So we would put a -infinity here with the x in the middle and the positive infinity here. So x is somewhere in between -infinity and positive infinity because it stretches the whole x-axis. So this is one way to say it. But there's even an easier way to say it. We could just say that means all real numbers. So that's an easier way to say it. So you could say negative infinity to positive infinity for x, or it's just all real numbers. Now the range is very similar. The range, I like to, put my pencil going this way, and I like to go down to up. Again, this is pointing infinitely down. So in the y direction, it's also negative infinity. And as I move my pencil up, it would go towards positive infinity for y. So it's almost the exact same thing. The only thing that changes is that we're not talking about x values, we're talking about y values. So again, it's going to be negative infinity for the range, but this case it's going to be a y. Or again, we could say all real numbers. So linear functions, unless they are either horizontal or vertical lines, they're going to look, this is pretty much going to be what linear function is, all real numbers, all real numbers. All right, let's get to example number 3. Our friend, the parabola, which is a quadratic function, and this part right here, this point right here, -4, -5, this is what's called the vertex or turning point of the parabola. And it looks like a U, but it does extend infinitely up this way because we got the arrowheads here and here. So let's start with the domain. The domain, see how it's pointing to the left a little bit? It's tilted a little bit that way. And it's also tilted to the right this way. So that means it's going to cover, eventually, all of the x values from left to right. All right? So just like the linear function, the domain is going to be all reals. And I'm just going to start saying all reals when it is that way, because I would go from negative infinity to positive infinity. So let me write that down, all real numbers. And I'm going to even abbreviate numbers to be like that. All right, the range, though, gets different. When I start from the bottom here with my pencil for the range, I don't hit it towards negative infinity. The first place I hit the graph is at a y value of -5. So the lowest value is a -5, and it goes up towards the maximum value, which would be infinity, because it keeps going up and up and up and up. So in this case, we can't just say all reals. We have to say that it starts at -5 and it goes towards infinity. So we do that by saying, this is where we use the and notation again. So it would be a -5, and it includes -5. So we're going to use less than or equal to. It's a closed circle there, it's on the graph. We say y, but with infinity, we use the strictly less than, because you can never reach infinity, you can never equal infinity, it's always less than, you can always go one more number. All right, so the domain would be all real numbers, the range would go from -5 to infinity. All right, and if you think about the range, it's really the minimum and maximum value. If you're good with the minimum and maximum, that's really all you got to put. All right, one more example. It's going to be a square root function. And I'm actually going to draw this in because it's hard to find a good graph of it. So a square root function, if it's just the square root of x, they look something like this. They start at 0, 0, and they kind of start up, and then they go like this, and then they gradually increase like this. And we get an arrow. So this would be a pretty classic square root function. So as far as the domain goes, well, as I'm going left to right, I don't hit anything on the graph until I get to 0. All right, so the first value is 0. So I'm going to write that in, and it's a closed circle. So I will make that less than or equal to. This is x. And it goes off to the right with an arrowhead, so that means it's going to go towards positive infinity in the x direction. So again, the square root function is going to be less than infinity. Now the range, going from bottom to top, think minimum and maximum. The minimum value, or when I first hit the graph from the bottom, is I hit it at 0. And as I keep going up, since this is still going up, even if it's going up gradually, it's still going up infinitely. In the y value, the maximum would be infinity, so it's going to go from 0 to infinity in the y. All right? Cool. So I guess we are ready for the SIA questions. I've got 2 pages of SIA questions, and the directions are the same for all 4 questions here. What I want you to do is find the domain and range for each of these. You don't have to copy down the diagram. All I want you to do is list the domain and range. So I'll linger on this page for just a second. Here's questions 1 and 2. So you want to pause the video here or go backwards and get them both. And 3 and 4 look like this. And this is the kind of video, the domain and range is a tricky topic when you're first learning it. I know when I first learned it, it confused me a lot. So one advantage you have is you can watch the video multiple times until it starts making sense to you. And you can always come see me during activity period and ask me questions too. Be happy to help you out. So anyway, thanks for watching. See you in class.